All right, let's do this one. We're going to factor it. We're going to find the roots, the x-intercepts, y-intercept, local max mins, and in behavior degree, increasing, decreasing, and when it's greater than 0. So let's start off by taking a look at it. So let me pull up my laptop here. I think I have it on Desmos. And let's see here. Come on. There we go, laptop, Desmos. And I've already typed it in. So let's zoom in. Okay, so I've got the scale changed here, but it comes down, goes up, may go up and come down. Then when we looked at it, zoomed out, it goes up, comes down, and goes up. Looks like it crosses at near 5. Let's see, let's click on it. This place is negative 5.193. And then looks like there's one at negative 4. And zoom in here. One at 0. One at 0. A little hard to get all this organized on the desk. 0. Under the dock cam. That one's not a 0. That's up above the y-axis. That's 0.193. 0.193. And that's below. So this looks like it's right here is a local, a high spot in this area, a local maximum. Local maximum at 0.122 is where it's at, but the local maximum is the maximum is 0.017. That's the local maximum. It happens to be at this x value, but the maximum is that, so that's what I would put down. And there's a local minimum right there at, I should write it this way, negative 0.163 is the local minimum. You can put, if you want to, at x equal 0.402. That's the place I'm looking at. But I wanted the 0. And it looks like there's a 0 at 0.5. Now, the degree tells me, that there should be 6 roots. 1, 2, 3, 4, 5. But if I look carefully at this, it does a bounce here. It comes down and then it goes back up because this is higher. So it's a bounce at 0. So that's a double root. So if I'm doing multiplicity, this has a multiplicity of 1. This one has a multiplicity of 1. This one has a multiplicity of 2. This one has a multiplicity of 1 and multiplicity of 1. And the multiplicity of 2 says there's a factor twice, and 0 says it's x. The factor is x twice, so it's x squared. Do I see an x squared in all of this? And I believe I do, so I can factor out the x squared. And that would leave me 2x to the 4th plus 17x to the 3rd plus 29x to the 2nd minus 27x plus 4. So that's the first factoring. The 0, 1 is an easy one and should be pulled out right away. if there was a constant in all these, that also should be pulled out, but there isn't. That goes in evenly and nicely. So the next thing I'm going to do is try to find the nice ones, and -4 looks like a pretty nice one, so that means if I'm going to do long division, I do x plus 4 into this. And so x plus 4 into this part only, which would be a long division. I put the sign the wrong way here. 2x to the 4th plus 17x to the 3rd plus 29x squared minus 27x plus 4. X times 2 and an x to the 3rd would make this. 2x to the 3rd times x makes 2x to the 4th. So I multiply 2x to the 3rd times x. I multiply 4 times 2x to the 3rd, and I get plus 8x cubed. And then I draw the line and change the sign so I can add. And add those two, I get 0. Add these two, and I get, let's see, 9x to the 3rd. The rest of this comes down, plus 29x squared minus 27x plus 4. X times what makes this? I guess that would be 9x squared. 9x squared times x is 9x to the 3rd. 9x squared times 4 is plus 36x squared. Draw the line, change the sign so I can add. These add to be 0. This adds to be negative 7x squared minus 27x plus 4. See that negative 7 times x would make that, so negative 7x times x is negative 7x squared. Negative 7 times 4 is negative 28x. Draw the line, change the sign so I can add. Those add to be 0. This adds to be plus 1x plus 4. And 1 times this would make this, so plus 1. And it went in evenly. So yes, x minus 4 is a 0, and a factor is x plus 4. So far I know there's an x squared, I know there's an x plus 4, and we will continue on with this, and so we have 2x to the 3rd plus 9x squared minus 7x plus 1. And we're going to divide by the other nice one, which was 0.5, or a half. And so if half is the 0, x minus 1/2 is the factor. So x times what makes this? 2x squared. 2x squared times x is 2x to the 3rd. 2x squared times a half, a negative half, is negative x squared. Draw the line, change the sign so we can add. This adds to be 0. This adds to be 10x squared. Bringing down the negative 7x plus 1. What times x makes this? That would be 10x. 10x times x is 10x squared. 10x times a negative half is negative 5x. Draw the line, change the signs, and I add these, and I get negative 2x plus 1. And multiply by negative 2 times x makes negative 2x. Negative 2 times negative half is plus 1. Draw the line, change the signs, add, and I get 0. So that goes in evenly. So another factor is x minus 1/2. And I have this left, which is a quadratic. It doesn't appear to factor normally, so I would use the quadratic formula. So I'd have opposite of b plus or minus the square root of b squared, which would be 100 minus 4 times a times c, and 4 times 2 is 8, times 2 is 16, plus 16, all over 2 times a. Although I do see that there's a 2 in all these, so probably I should have factored that out and put the 2 out here, and then I would have had x squared plus 5x minus 1. And this would reduce, but I'm going to use this in the quadratic formula, so the opposite of b plus or minus the square root of b squared minus 4 times 1 times minus 1 is plus 4 over 2a, which is 2 times 1 or 2. And so my other two zeros are negative 5 plus square root of 29 over 2 and negative 5 minus the square root of 29 over 2. That's what these two numbers are. So my factors would be x minus negative 5 over 2 plus square root of 29 over 2. And then the last one would be x minus negative 5 over 2 minus the square root of 29 over 2, 29 over 2. And minus that whole thing, which actually turns that all to positive. There's the completely factored. There's the decimal approximations of the zeros. Here are the two here that could be replaced with exact values, which I asked for. And the x-intercepts now we have are 0 gives us 0. Negative 4 gave us 0. This 1/2 gave us 0. And negative 5 over 2 plus the square root of 29 over 2 is gave us 0. And the final one is negative 5 over 2 minus the square root of 29 over 2 gave us 0. So there's the x-intercepts. And they all should be written as points. And the y part, which should always be 0 because they're on the x-axis. The y-intercept, you put, if you're going to be on the y-axis, you put in 0 for the x, and 0 into here comes out to be 0. If there was a number added on, that would be the y-intercept. So far we've gotten a couple of a local max, a local min, and all of this. Okay, let's go back to the graph now and find the other max and mins. Okay, so this one up here, and so we need to go up there, and I'm going to squeeze this down. We're going to go up to there, and we find a local max of 446.236, local max of 446.236, and that's what I wanted when I want the local max. You can tell me at x equal negative 2.873 if you want, but that's not necessary. That's what the local max is, the 446. And then there's a local min down here. You can see it as negative 389.2027. Negative 389.027. You can tell me, not necessary, at x equal negative 4.734. This is the local min this is local min, this is local max, and local max. We got all those. In behavior, since this is degree 6, the left side, both sides are going up because it's a positive 2x squared. If it was a negative 2x to the, not squared, to the 6th, both ends would be going down. So we're going to say both ends head to positive infinity. If they were opposite, I'd say maybe the right end goes, or the positive end, the right end goes up, and the negative end goes to the negative infinity, or something like that. Degree was 6. We said that already. When is this increasing? Well, it's coming down, so that's decreasing, and then it increases, then it decreases, it bounced and went up, and then went down, and then up. So we're going to have to look a little closer at things, but it's decreasing to that first local minimum. So I'm going to pull this out of the way. I'll do a rough sketch of what it looked like here, I guess, so that you can see it. It went down, came up, bounced at 0, went up, and went down like that. So it decreased all the way up to there. Decreased up to that local minimum that was way down there here. So it's decreasing from negative infinity to that x value, negative 4.734. That's where this number becomes important, is to knowing when it quits being decreasing. Then it increased, and you notice I'm not including this. At that point, it's changing from increasing to decreasing, so you don't use square brackets. It started increasing from negative 4.734 to that maximum, that high maximum in there, this one, which was 446, and that happened at negative 2.873, negative 2.873, so it increased to there. Then it decreased to 0. So from there to 0, negative 2.873 to 0, it decreased. Then it increased after 0 for a short time to that local maximum, which was at 0.122. So it's increasing from 0 to 0.122. Got to that little high spot, and then it went down to that low spot there. So from 0.122 to the next local minimum, which was at that value, 0.402, it decreased, and then it increased the rest of the way from 0.402 to infinity. It increased. The last thing I ask here is, when is this positive? Well, everything that's above 0, and 0 was right there, everything above 0 is when the f of x, y, is positive. So it was positive from negative infinity to that first 0, which was at negative 5 point something, negative 5.193, or more exactly, negative 5 halves minus square root of 29 over 2. That would have been a better number to put in there. And then when it came back up, which was at negative 4, at negative 4 it was 0, so you don't include it. It was positive all the way till it got to 0. And then it went at 0, it was 0, so we don't include it. It was not greater than 0. If I said equal to, then you would include the 0. And then from 0 to the next 0, which was 0.193, it was positive, and then it went negative, and then it came positive again after 0.5. So 0.5 to infinity, it was positive. Positive. That y was greater than 0. Okay, that's all of that. So now I want to talk about how to do these long divisions with synthetic division. All right. To do synthetic division, we use the actual root, the 0, the -4. The factor is x plus 4, but the 0 is -4. So we put -4, and then we put the coefficients of the polynomial in decreasing order. And we have x to the 4th, x to the 3rd, x to the 2nd, x to the 1st, and no x's. So they are all there. If there was one missing, we'd have to put in 0, but they're all there and in decreasing order. So I put in the 2, the 17, the 29, the -27, and the +4. And just like we did here, this was 2, and it ended up being 2 since x going in here. So we just bring down the 2. But the key part of this was taking the 2 times the 4 to get this number, which was 8. And then we had to change the sign, but this is already sign changed from the +4, so -4 times 2 is -8. The sign changed automatically because we changed it here. So then we add, just like we added here, and we get 9. -4 times 9 is the key part. We put the 9 up here and times 4, and we got 36, and we changed the sign, but this is already changed, so -4 times 9 is -36. That key number had to be added to that, and we get -7. -7 goes in our answer, and -7 times 4, and change the sign, so -4 times -7 is the +28. That was key right here. And we add and we get 1, and 1 times -4 is -4. We add and we get 0, which is what we did. 1 times 4 got the oh, I didn't put that. 1 times x plus 4 is x plus 4. Draw the line, change the signs, and we get 0. So there's our remainder. And right here is the answer we got. Up here, this was x to the 4th, and it became 2x to the 3rd plus 9x squared minus 7x plus 1. There is that. Then we did x minus 1/2, or the 0 plus 1/2. So I'm going to put the 1/2 in here. The 0 was 1/2, and so I'm going to put the 1/2 in. And I'm looking now at the black, ignoring the red. And just like we did before, we brought the 2 down. We're going to bring the 2 down, multiply by 1/2, and we get 1. We're going to add, we get 10, which is what we did. We're going to multiply by 1/2, we get 5. We're going to add, we get -2, which is what we did. 1/2 times -2 is -1, and we're going to add, and we get 0. This was x to the 3rd, so this becomes x squared plus 10x minus 2, which is what we had right there. So this is all the space it takes to do all of this stuff. We're down to a quadratic, and we would then factor out the 2 like I did here, and then do the quadratic formula, and we'd have the answer to that. Okay,